Hello, hello, wherever you are on this perplexing planet called Earth. I hope wherever you happen to be located, you're having a tranquil day, evening, or night, wherever you happen to be. On my channel today, I'm going to be talking about nodes. Specifically, I'm going to be talking about the one that I see used the most. That math node. I've looked at many YouTube channels. I've gotten some videos off of Udemy. And every time I see them, the number one texture or node that he uses is that texture coordinate node. That's simple. They do generate, mirror, object, camera, straightforward. The one that they use the most is called object. But when you're learning about nodes like I am, that's going on my 4th week learning about nodes, they perplexing. Now I'm feeling comfortable with them. I am. It's not daunting when I first learned about nodes in Blender 2.76. I never even dabbled with it. But now I know about the procedural nodes, and I know how the nodes is different from the compositor. I know how it's different. The compositor, like I said in other videos, it adds like flash to the whole scene. Those nodes, the procedural or shader nodes, they cover a certain aspect of your scene, like a certain object. That's how it's different from the compositor. Before I go on, I want to thank this man right here, wherever he happened to be, Sam Bowman. You should go view some of his videos. He have a plethora. He have a number of videos of showing how to manipulate those nodes. In particular, he's manipulating, like I said, most people they manipulate that math node to create their own unique textures. That math node to make them different texture shapes like tiles and stuff. They use that math node to make tiles and stuff like that. You know, Voronoi, Musgrave, they good for straightforward things. But when you want to make your own texture like patterns on a shirt, floor text, tiles, and all that stuff, you know how the tiles. Now I don't mean like the rectangular tiles. I mean the tiles that have the sheets. The wooden tiles. They had that long rectangular part, and they go in that V and W shape. Those math node does that. So I said, check out Mr. Sam Bowman. He was a big help to me today. But I want to go over something a little bit more involved. They never really tell you how or why the node works the way it works. So I want to go over, not in great detail, but I want to give you an idea of why the math node behaved the way it behaved. So let me hide this. I bring that on. I'm going to bring in my graph 1. Alt H. Oh, hide him. I can delete him now. I'm done with him. I just delete this. I'm going to go into my shader. And I guess when I move this cube, let me see. I want to move this cube over some more. Okay, that's good enough right there. And I can hide. I'll hide my graphs for now. I'll hide them all for now. And I'll come back and explain them later. Alright, so you see right here, simple setup. Simple setup. I can minimize all the others. My main focus on, I'm going to zoom in so you can see it. So you can see it clear as day. I can bring this up a little bit more too. You can see I'm using them all. Now, let me go with the most easiest one. Add. What in the world does add do? Oh, I need one more thing too. Well, I want to click on this. Yeah, that's the one I need. I have to click on my arm. Like, see, with them nodes, everything got a node. Everything has a node. So I have to click on my cube to use the nodes just for my cube. I want to focus on just 2 of them, so I can minimize the ones I don't need. This, I don't need this. I don't need the materials, so I can hide these. The ones I really need, they just separate X, Y, Z, and the add node. Now, you may be under, see, like I said, they don't tell you what it's for. What does the add node do? Now, let me get my pen. Before I go on, we should all know this. When I have this X, it goes from greater than or equal to. I should change my pen another color so you can see it better. Hold on, I'm going to change it better. Oops. I come here. Let me hit N. I'm going to change this to, I'll make it black. So you can see that better now. So X is greater than or equal to 0. Make my 0 better. 0 less than or equal to 1. Oops. 1. Now, 1 is white and 0 is black. So, ingest that. That's important with these nodes. 0 is black. 1, that puts it less than or equal to, is white. And everything in between is a shade of gray. Well, I look so crooked. I'm not going to worry about that. Sorry about that. Wow, I look crooked, people. I'm sorry. A shade of gray. So remember, and that's it right there. 0 is black. 1 is white. Now, as you see on my separate X, Y, Z, I'm just going to be working on the X. You can do it for Y and Z if you want to, but I just want to focus on one of them. All right, so I'm going to erase this because I have a premium space, as you can see. Let me see if I can erase this clearly. Click right here, annotate, erase. So that's important. So we got to keep that in mind. 0 is black and white is 1. So let me bring this back over. Oops, let me move my pen. Let me move this over. So we know right here. So 0 is black, white is 1. Now over here where you see my mouse at on the XYZ, this X right now is 0. And if you see it in the add node right now, the value is 0. So technically, let me change my color. I'll take it off black. I'll make it light. I'll make it a greenish color. So technically, right now, 0 is right here. Let me do that again. This is 0. Right there. Where that dot at. That's 0. So we understand. So understand that. That's 0. Now, I'm going to be manipulating this. So, what happens when I add 5/10 or 0.5? Let me do that right now. 5/10. So you see, it's close to 1. So it gave the area more white. The black is disappearing because 5/10 is approaching 1. What happens if I give it negative 5/10? That should be more on the black side. So you see, it adjusted because negative 5/10, which is less than 0. Anything that's negative is less than 0. If you remember that. So let me put it up here. Anything when X is less than or equal to 0, remember, black. So anything less. So I'm just going back to a little bit of pre algebra. Negative 0.5 is less than 0. 1, you definitely know negative 1 is less than 0 or X, and so forth. So understand that If it's negative, it's going to be black. So I added more negativity to it. So it's black. So I hope you got that. Let me come back down here to my dang. So now I'm gonna make it 1. So 0 plus 1 is 1. So all of us should turn white. And that. But this little edge didn't turn white. Because this little edge right here is still 0. But let me see if I make it 2, what will happen. See? Now it took care of the whole thing. All of us white. So that's what the add do. So let me put it back to 0 where it was before. And I just go to subtract. And you know subtract is basically the opposite of addition. See, the opposite of addition. So if I gave it a 1, if I just put 0.5, there it is right there. I'm still subtracting 0 from 0.5. Oh, this is what I'm doing right here. This is the math right here. If I can write on here. 0 minus 5/10 equal to negative 5/10. So that's why I added more black. That's why I added more black to it. So like I said, check out. Now Mr. Sam Bowie, he didn't teach me this. I had to figure this math part out on my own right here. I had to figure this out. So what will happen if I add negative 5/10? Or negative, yeah, I'm going to say negative, negative 5/10. See, it turns it white. Because you know when you had algebra, remember, when I said right here, 0 minus negative 5/10. If you remember your math, negative. When the two negatives, I'm not going to explain all, say multiplication, but you remember when you took math, when two negatives are beside each other, it becomes a positive. So it becomes positive 5/10. And you know, basically, if I put the parentheses around here, then you know it's definitely multiplication. But parentheses definitely mean it's multiplication. So negative times negative give you a positive, and that's why it became more white. Even, and now I'm on subtraction mode. It would go like that way for the other ones. So I just wanted to explain that. Now I'm going to let me erase this. Erase all of this. So I'm gonna skip multiply and divide, cause that's still in the basic math group. So you can understand that. I'm gonna go into the power where it gets a little bit more tricky. Let me activate my graph 1 and explain this one. Oops, I gotta still keep it in my. Well, I'm gonna activate graph 1, Alt H. Click back on my cube, cause I'm working on my cube. I can hit and bring it over so you can see it a little bit more better. No, but I don't want that. I want to hide this. Hide this. Now my graph 1, it's supposed to show a line on here. It did earlier. Hide that. Alt H. Oh, but it brought all of them back. So hide. I want to say Alt H. So sorry for this, people. I just want to hide certain ones. Hide this. Hide that. Alright, but it's not showing it, so I'm just going to sketch it. Now, I'm using my hand, so I don't have a ruler, so it may not look pretty as I would like for it to look. Let me click on this. See? I had this all set up, but it's not showing my line right there. I'm not going to try to figure it out. So I'm just going to sketch it by hand. Can I write on here? Oops, have it on the wrong one. All right. I'm going to change it to black. Bring it down to black. Here's my axis right here. This is my x-axis. Here's my y-axis. Y. And here is how the linear line should look. Like I said, I'm sorry it didn't show up, but I'm doing it by hand. Whoops. I don't want it right there. I want to go right through the origin. So I'm going through the origin right there. Bringing my line down. And everybody had, if you remember your algebra, you remember the equation for a line, which is y equals mx plus b. That's the simple equation that I'm using right there. Or you just could say y equals mx. Because in this case, I think b is 0. But hey, but let's move on. So that's it. Now, this is what I discovered. Like I said, nobody told me this. I had to figure out on my own. On this side, right here, this is, I can call this, all these values is negative. But when it's negative, it covers the whole area. So right here, where my mouse at, the negative part, everything less than, remember, everything less than 0 is black. Let me say that. Everything, I'm going to write it right here. Remember, everything less than 0 is black. And remember, right here, on this cube node, I'm using the x value. So it just focuses on the x. It's just focusing on x. If x less than 0, all of this part right here is going to be shaded black. So that's why this whole side is black. Because every x is less than 0. On this side right here, I want to get rid of something. This looks irritating to me. I want to get rid of this right here. On this side right here, x is less than or equal to 1. But on this side, I have 1, 2, 3. Even if it's bigger than 1, so this whole side is going to be white. And that's it, good people. That's why that whole side is white. And I'm not going to add no values to it. I'm gonna put a 0 right here and see what happens. See, I put 0 there. I'm not going to add no values to it, because when I add a value to it, that's just like, I'm just doing simple addition. Oh, but hold on. I think I wanted to have the power mode on. Power. But it's still the same thing, you see? And here's the exponent. When x is equal to, I should put x equal to 1. Because, well, 0, when it's 0, when you notice, if you, in basic math, I'm going to erase all this stuff right here. So I'm done with this. I can erase all of this. Let me see if I can. Oops. I don't care. I erase all of this right here. So, I explain that graph right there. Now, I'm going to change my exponent to 2, and we're going to explain that. Like, because remember, I only learned this today. When I learn something, I like to share it fast. I learned it today. So, if I make any mistakes, please forgive me. I just now thought this today. I didn't spend no months thinking about it. I said, it came to me, let me make the video. That's how I like to make the video. It's quick and fast. Alright, so, my exponent 1. So, my value should be 1. But it's still based on that graph. Let me erase this too. Okay, good. Now I'm gonna try something. Okay, let me click back on this. Oh, power. I'm gonna just do something. 0. And there. That's what I want to go. But see, when I kept switching between my shape, you know, like the graph and my cube, that messed me up. All right, so I want to say this right here. When X, remember, it's X right here where my mouse at. When X is 0, if you remember your basic math, that's 1. And when it's 1 or more, greater than, when X is greater than or equal to 1, remember, it's going to always be white. So my exponent is 1. So the whole thing is white. See, nobody ever told me that. That will help you making your own tiles. See, now since I know that, it's going to help me out immensely. I know the math part behind the math node. I know the math part. I'm not just throwing a math node out there that's making anything. I understand the math. So let me erase this. Like I said, I'm only going to go to the third power. I don't need to go no higher than 3. I'm explaining all the powers as best as humanly possible. So right now, I did it with the power 1. I explained that just a few moments ago. Now, let's go to the power of 2. Right there. Now, I hope the second graph works. Let me see if I can hide my first one. Hide. Let me see if I can bring back my second graph. Alt H. Okay, there's my second one. Good. Hide this one. Hide that one. Now, you may be wondering, why is the center area black? I know why. I know why. I'm going to tell you why. If you see right here, my graph, it goes from -2 to +2. Here's 1. This the central area right here when it's 1 and -1. Now, in between here, there are decimals. Decimal values. And if you see over here on my graph over here, you see the edges are more gray. They're gray. It gets grayer and grayer as I go to the edges. The reason why, like I said, is decimal values. So over here, if X becomes equals 0 and 5/10, that's close to 0. So it's going to be gray or black. If I get to 0 and 5/1000, that's extremely close to 0. So that will become black. You see the beauty in it? And this graph right here, you see how the graph look? It's staying over here. It's staying with the graph. I'm doing it by hand, so it's ugly. But it's basically staying with that graph. But you know, just doing it to the Blender version. And remember, it's only one about the X values. So up here, all of this part right in here, all of this, from the top to the bottom, is some form of black, all the way up. Some form of black or gray. Because it's not worrying about the actual shape of the graph. It is worrying about what value is X. So that's why it's linear over here. It's not worrying about the shape, it is worrying about them values for X. And all the values for X that's close to 0 will be some form of black. See, I understand that. See, some things people not going to tell you on YouTube. That's why, see, because and even on the other side, the negative side right here, I have -5/10. Still close to 0. I have -5/1000, which is even more close to 0. So this will be a gray color. gray, and this will turn blacker. Blacker. So beautiful. Remember, it's a power of 2. It's not worrying about the power that we learned in this, basically in algebra 2. It's not worrying about the graph of algebra 2. It's just worrying about the x values and all those points on your object. Remember, it's worrying about all the, like when I had those dark things, those are the points. All those points is where x equals -5/10 or -5,000 or +5/10 or +5,000. But remember, it's close to 0. I had to think about that very intently. Okay, so I hope you understand when it's to the second power, what does that mean? What does it mean? So we have to think about how these nodes, the math node, like I said, that's one of the most powerful nodes and all the nodes from what I see in my short time dealing with nodes, a month or so. I've seen people time after time kept manipulating that math thing. Okay, so we're done with that one. I can hide this one. And I'm going to do my last one, and then the video will be over. So I hide all of them. Hide this. Hide that. Now I want to click back. I got to click back on this. And I want to change the power to 3. And we're going to explain that. Alright. Like I said, this whole side right here, x is negative. Whoops. X is negative, which is mean it's less than or equal to, x is less than, or I'm sorry, 0 is greater than or equal to x. So if it's less than or equal to 0, this whole side will be black. And as we see, all of this side, let me move my over here. All of this side, change the color to a reddish color. All of this side right here is black. Now the middle part right here, I'm going to zoom in. I don't know if I should zoom in. I'm going to zoom in a little bit more so you can see it better. You see right here, this middle part that looks flat, the values are getting close to 0 right there. So that's why over here it's sort of gray. That's why right here it's gray. For those values that's like I said, 3/10 or 3/100 or -3/10 or -300. Now I'm sorry for the math, but that's why it's called math node. You gotta understand those functions, like the logarithmic function, the exponential functions. You must understand all of them. But luckily for you, good people, lucky for you, when I keep seeing people using those making their own little tiles or whatever, I keep seeing them use that multiplication thing the most. So you should master multiplication. It's basically based on that addition and stuff. So now you got an idea of what in the world does those colors, specifically black, white, and gray, mean? When we was in school, when we saw x to the second power, we say parabola. But in here, It's not the variable, it's those x values that I care about. When we see the cubic in Algebra 2, we got the graph in our head, but the computer is not thinking about the graph. It's thinking about the values where x is negative, or x is close to 0, or x is equal to or greater than 1. That's all it's thinking about. That's it. So I hope this gives you a little bit of insight into the mathematical foundation of why these nodes, when you use the separate X, Y, and Z, or the RGB, it's the same, basically the same thing. Why is one side black? Why is one side white? It's based on mathematics. So, thank you for stopping by. Blender family, 3D family. I hope this mathematical explanation of the math node help you in understanding how to manipulate it, because it was going to help me out immensely. How to manipulate it. Till the next time, Blender family. Peace.